So when we see an integral like this, we're immediately thinking trig sub, especially considering it's an x squared, not just an x term. So what we're thinking is we're going to have to find a way of converting this into a form where we can use a trig identity to reduce this down into a single term, which we can hopefully then integrate. Now, if you know this, you know this, otherwise it might be a bit difficult, but we have the 4 there. Let's rewrite that as 2 squared, just to make our lives a bit easier. And then we'll see we have our x squared here. So we want to match up the coefficient of this new term here with this 2 squared. And, well, since it's going to be squared, we want to take the inside part of that, if that makes sense. And we're going to be looking for some identity here. So the identity we're going to be using is 1 plus tan squared x is equal to secant squared x. This is what you get when you have sine squared x plus cos squared x, and you divide everything through by cos squared. Okay, so using that identity, let's use substitution. X is equal to 2 tan theta. There we go. So then our differential is going to become 2, and then derivative of tan is secant squared theta d theta. So this 2 squared becomes, if we put everything in here, 2 tan theta squared multiplied by 2 secant squared theta d theta. Now we'll just carry on here. I'll put this in a box. I'm gonna factor out the 4 from the front, and we'll leave it over here. And oh, I actually need to change these limits as well. So we're going from x equals 2 to infinity. Putting that into theta, we're going to get tan theta is equal to 1. So the first feature is going to be pi over 4, and then when tan theta equals infinity, second limit is going to be pi over 2. So we're going from pi over 4 to pi over 2. Factor out the 1/4 at the start, and then we have a 1 over 1 plus tan squared, which we know is going to be secant squared. And we have the secant squared on top, so that cancels out nicely, leaving us with just integrating a half dx, because the 2 and a 4, and that's going to give us 1/2, sorry, I meant d theta, 1/2 theta d theta. And now substituting everything in, we get 1/2 pi over 2 minus 1/2 pi over 4, which is going to be 1/2 times pi over 4, which is pi over 8. So thanks for watching, and that was a quick and simple further maths integral. See you in the next video.